All right, buckle up everyone, because today we are taking a deep dive into some seriously mind-bending stuff.
Oh, yeah.
We're talking about the very fabric of reality.
I bet.
Your sources have been hinting at this idea of information density, and it's not just about how much data you can cram onto a hard drive.
Right.
This is about the possibility that information itself might be the fundamental building block of the entire universe.
That's a fascinating concept.
It really is. It's like you're not just asking what the speed of light is or how gravity works. You want to understand the why behind it all.
Absolutely. And that's where information density comes in.
So how does this information first view of the universe, how does that change things?
Well, it really challenges the way we traditionally think about physics.
Okay.
Instead of starting with solids and forces and energy,
Yeah.
what if it's all just information at the most fundamental level?
Like a cosmic code underlying everything.
Exactly, like
Yeah.
a giant cosmic computer program.
You know, I did come across this phrase, it from bit, coined by physicist John Archibald Wheeler.
Brilliant mind.
It is such a simple phrase, but it really gets you thinking.
It does.
What if everything we see and touch and experience is just different arrangements of information?
It's a mind-blowing idea.
Mm.
And it has the potential to answer some of the biggest questions in physics.
Okay, like what? Give me an example.
Well, take the speed of light, for instance.
Okay, the speed limit of the universe, right?
Right. It's always presented as this universal constant, but
Why is there a speed limit at all?
exactly, from an information density perspective, the speed of light might not be about the photons themselves,
Okay.
but a fundamental property of space-time itself.
So imagine space-time as this vast network.
Yes, constantly processing and transmitting information.
So the speed of light is like the maximum rate,
The maximum rate at which information can travel through this network.
like a cosmic refresh rate.
Precisely. Yeah. It's the speed at which the universe updates itself.
Okay, so instead of thinking of light as this thing that's inherently fast,
Mm-hmm.
it's more about how quickly the universe can process information.
Exactly. And your sources talk about photons as units of information transfer,
Okay.
not particles in the traditional sense.
Right.
So the speed of light becomes a fundamental limit on how quickly information can be exchanged across the universe.
Okay. That's making the speed of light less about speed and more about a fundamental property of how the universe operates.
Exactly.
But what about mass and gravity?
Ah.
Those seem so physical, so tied to like the stuff of the universe.
Right.
How does information density fit into that?
That's where things get really interesting. Your sources suggest that mass might not be an intrinsic property of matter,
Okay.
but rather an emergent property of information density and coherence across different scales.
Hold on. Coherence. What does that even mean in this context?
Good question. Coherence in this sense refers to how organized and aligned information is.
Okay.
Think of a laser beam.
Right.
All the photons are traveling in the same direction with their information perfectly synced up. That's a system with high coherence.
Got it.
Now compare that to a regular light bulb. Photons are going off in all directions. Their information is much less organized.
So low coherence.
Exactly.
Okay, so higher coherence means the information is more unified,
Yes, more in sync.
like a well-coordinated dance troupe.
Versus a bunch of people randomly moving around.
Okay, I get the analogy, but how does this connect to mass and gravity?
Well, imagine a black hole.
The ultimate example of.
Extreme information density and coherence.
Right.
Its information is so tightly bound, so perfectly in sync, that it warps space-time in a way that creates intense gravity.
So a black hole's immense gravity isn't just about its stuff,
No.
but about the way its information is structured.
Precisely.
That challenges everything I thought I knew about gravity.
That's a different way of looking at things, for sure.
But if gravity is tied to information density, wouldn't the universe just collapse into one giant black hole?
That's a great question, and it gets to the heart of how we might need to rethink our understanding of gravity. It's not just about information wanting to clump together,
Yeah.
but also about the interplay between coherence and the distribution of information across the universe.
So it's like a cosmic balancing act.
Exactly. There are forces that pull information together, increasing its density and coherence, and forces that spread it out.
Okay.
This dynamic tension might be what prevents the universe from collapsing into a single point.
So maybe gravity isn't just a simple force of attraction, but a reflection of this constant struggle to organize information across the universe.
It's a fascinating possibility.
It really is. It's like we've been given a new lens to view the universe through.
And suddenly things that seemed fixed and immutable are starting to shimmer with possibility.
I'm starting to see why you're so fascinated by this.
It's an incredible area of exploration.
It's like upgrading from a basic physics textbook to some advanced universe hacking manual.
And we're only just beginning to explore the implications.
Okay, so black holes, they're not just dense objects. They're incredibly coherent information structures. What secrets might they hold about the nature of information itself?
That's what we're going to explore next.
Okay, I am definitely intrigued. Black holes, gravity, the speed of light, it all seems to be connected to this deeper level of information.
It all ties together.
But where do we go from here? What other mysteries can we unravel by looking at the universe through this lens?
That's what we'll dive into next. Get ready, because things are about to get even more mind-bending.
Okay, my brain is still buzzing from that last conversation.
Yeah, it's a lot to take in.
It's like my whole understanding of the universe has been flipped on its head.
I hear ya.
So where do we go from here? What other mind-bending implications does this information density idea have?
Well, you mentioned black holes earlier.
Yeah.
And they're a perfect example of how information density challenges our assumptions.
Okay, I'm all ears. You've already convinced me that there's more to black holes than meets the eye.
We often think of them as these super heavy objects, right?
Incredibly dense.
But what if their mass isn't the most important thing about them?
Okay, I'm listening.
Think about this. As a black hole grows, it actually seems to weigh less relative to its size.
Wait, really? That sounds counterintuitive.
It does, right? It goes against everything we think we know about gravity.
Yeah. Shouldn't a bigger black hole have stronger gravity?
You would think so.
Yeah.
But remember, we're looking at the universe through this new lens of information density.
Right.
A black hole's information is so incredibly dense and coherent, so tightly woven together, that it almost transcends our typical understanding of space and time.
So it's like it's playing by a different set of rules.
Exactly.
Right.
Its information is so unified that it doesn't interact with space-time in the same way as less coherent objects.
Mm-hmm.
It's almost as if it's achieved a state of perfect balance, a kind of cosmic zen.
Okay, that's a pretty wild concept.
Yeah.
So if black holes are these ultimate information sinks,
Yeah.
what happens to the information that falls into them? It can't just disappear, can it?
That's a question that's puzzled physicists for decades.
Yeah.
It was initially thought that information was destroyed within a black hole.
Right.
But that would violate some fundamental laws of physics.
Okay.
What seems more likely is that the information gets encoded onto the surface of the black hole, its event horizon.
So it's like the information is stored on a cosmic hard drive.
It's a great analogy.
Okay.
And over incredibly long timescales, that information slowly leaks back out through a process called Hawking radiation.
So the black hole is slowly evaporating, releasing the information it has absorbed back into the universe.
Precisely. It reinforces this idea that information is fundamental,
Okay.
that it cannot be created or destroyed, only transformed.
So in a way, black holes are like cosmic recyclers,
You could say that.
taking in information, processing it, and eventually releasing it back into the universe.
It's a beautiful cycle.
Okay, so black holes are these incredibly complex information structures.
Uh-huh.
But if we zoom out and look at the universe as a whole, it makes you wonder if the universe is essentially a giant information processor.
Right.
Who or what is doing the processing?
Now you're getting into the really deep questions. I know, right? The kind that philosophers and physicists have been grappling with for centuries.
Yeah, like, are we just a simulation?
Exactly. Some suggest that consciousness itself might be an emergent property of this cosmic code,
Well,
a way for the universe to experience and understand itself.
so we're talking about the possibility that the universe is not just processing information, but maybe even aware of itself.
It's a mind-blowing concept, and it highlights how this information-centric perspective opens up entirely new ways of thinking about the nature of reality and our place within it.
It really does. It's like we've been given this amazing new puzzle to solve.
And we're just starting to put the pieces together.
I definitely feel like we've gone from a black and white picture of the universe to a full color, high definition experience.
I love that analogy.
But before we get too lost in the philosophical implications, you mentioned that there was something else in my sources about the speed of light.
Yes. You remember how we talked about the speed of light being like the refresh rate of the universe?
Yeah.
What if there was a way to, in a sense, overclock that refresh rate?
Are you saying we could actually make the speed of light faster?
It might not be as unbreakable as we once thought. Remember, we're looking at the speed of light as a property of how information travels through space-time.
Okay.
What if instead of trying to make something move faster than light, we manipulated the fabric of space-time itself?
Okay, you're going to have to explain that one a bit more.
Imagine creating a warp bubble around a spaceship.
Okay.
Inside this bubble, the information density of space-time is altered, effectively increasing the speed limit for information transfer.
So the spaceship isn't actually moving faster than light within the bubble,
Right.
but it's traversing space at an incredibly accelerated rate compared to the outside universe.
Well, exactly.
Wait a minute. Are you talking about warp drive? Like straight out of Star Trek?
It might sound like science fiction,
It does.
but there are theoretical frameworks like the Alcubierre drive that explore this very concept.
Really?
And while we're nowhere near having the technology to create such a warp bubble,
Yeah. The very fact that we're seriously considering these possibilities shows just how much our understanding of the universe has shifted.
that's incredible. So instead of trying to break the speed limit, we're bending the rules of the road itself.
Exactly.
But wouldn't that require an insane amount of energy?
It definitely wouldn't be easy. The theoretical energy requirements for creating a warp bubble are mind-bogglingly huge.
Yeah, I can imagine.
But who knows what the future holds? Maybe one day we'll figure out how to harness the power of information density to achieve what once seemed impossible.
Okay, warp drive is definitely a concept I'm going to need some time to wrap my head around.
It's a lot to process.
But it highlights just how much potential this information-centric view of the universe has.
Absolutely.
It's like we've been given a glimpse of a future where we can manipulate reality itself.
And that brings up some important ethical considerations.
Right.
If we do gain the ability to manipulate information density on such a grand scale, we'll need to think carefully about the implications and consequences of our actions. That's a good point.
Yeah.
It's like we're on the verge of unlocking the universe's source code. But we need to be responsible developers.
Absolutely.
But before we get too ahead of ourselves, I think it's time to take a step back and try to synthesize everything we've learned so far.
I agree. It's been a wild ride.
It really has. And we've covered a lot of ground.
We have.
What stands out to you the most? What's really resonating with you about this whole information density idea?
That's a good question. I think what's really striking me is how this perspective shifts our focus from the material to the immaterial.
Okay.
It's like we're moving beyond the stuff of the universe and recognizing that information structure and organization might be the real driving forces.
It's a profound shift in perspective. And it raises even deeper questions about the nature of consciousness, the origin of the universe, and the ultimate fate of information itself.
Those are the questions that keep me up at night.
I'm starting to see why you're so passionate about this. It's not just about physics, it's about philosophy, about exploring the fundamental mysteries of existence.
Exactly. It's about asking the big questions, the ones that have always fascinated humanity. And information density seems to be a key that unlocks new ways of thinking about those questions. But before we dive into that philosophical rabbit hole, there's one more aspect of your sources I want to touch on, something that might make this whole information density concept even more tangible.
Okay, I'm intrigued. What else have you got up your sleeve? So we've gone from the speed of light to black holes to warp drive, all because of this information density idea.
It's quite a journey, isn't it?
It is. Where do we even go from here? It feels like we've opened up a whole new universe of possibilities.
And that's what's so exciting about this perspective. It changes how we see everything. But you're right, it can also feel a bit overwhelming.
Yeah, a little bit.
So let's try to ground this a little bit, bring it back down to earth.
Okay, please do, because my head is still spinning with all these cosmic concepts.
Well, your sources actually point to some really practical experiments that are happening right now that are testing these ideas.
Wait, really? So this isn't all just theoretical? People are actually manipulating information density in labs?
Absolutely. One area is in supercooled quantum systems. Remember how we talked about coherence being linked to mass and gravity?
Yeah, like how a laser beam is super coherent.
Exactly. Scientists are exploring whether by supercooling certain materials to near absolute zero, they can create systems with incredibly high information density and coherence.
Okay, so we're talking about making matter so cold that its information becomes super organized.
Precisely. And the theory is that if we can achieve a high enough level of information density, we might actually see a reduction in gravitational effects.
Hold on, are you saying we can make something way less just by manipulating its information state?
That's the idea. It's still early days, but the implications are incredible. Imagine being able to control gravity just by manipulating information.
That's insane. It would revolutionize everything from transportation to energy production.
Absolutely. And there's another fascinating avenue, entanglement-guided motion.
Okay, back up a second. What exactly is entanglement again?
Oh, it's one of the weirdest and coolest aspects of quantum mechanics. Basically, you can have two particles linked in such a way that even if they're separated by vast distances, they still instantly influence each other.
So it's like they're connected by an invisible thread no matter how far apart they are.
Exactly. And some physicists believe that this entanglement connection might be a form of information transfer that bypasses the limitations of the speed of light.
Whoa. Are you saying we could communicate faster than light using entanglement?
It's a possibility. And scientists are already experimenting with using entanglement to guide the motion of objects. It's like sending a message through that invisible thread and having it affect the physical world.
Okay, my mind is officially blown again. This is some next-level science.
It is. And it shows that we're just beginning to scratch the surface of what we can do with information density. We're talking about potentially rewriting the rules of reality as we know them.
It's a lot to take in, but it's also incredibly exciting.
I agree. It really is.
It feels like we're on the cusp of a whole new era of scientific discovery.
And you've done a fantastic job diving into these complex ideas. It's clear you have a real thirst for knowledge.
Well, I have to give credit where credit is due. You've been an amazing guide through this mind-bending landscape of information density.
The credit goes to you for asking the right questions and being open to these new perspectives.
So where do we go from here? What advice would you give to someone who wants to keep exploring these ideas?
I would say never stop questioning. Keep that curiosity alive. And don't be afraid to challenge your assumptions about the universe.
That's great advice. I think we've all learned today that the universe is full of surprises, and the more we learn, the more we realize how much we don't know.
And that's the beauty of it. The journey of discovery never truly ends. There's always something new to explore, a new mystery to unravel.
Well, on that note, I think it's time to wrap up this deep dive into information density. We've covered a lot of ground, but I have a feeling this is just the beginning of the conversation.
It certainly is, and I'm excited to see where this journey takes you and everyone listening.
So to everyone out there, keep questioning, keep exploring, and keep an open mind, because the universe is a vast and wondrous place, and there's always more to discover. Thanks for joining us on this deep dive into information density.